The research paper discusses the issue of hallucinations in large language models, LLMs, and proposes a novel method to mitigate this problem. By scaling the readout vector in a memory-augmented LLM decoder, hallucination can be achieved in a training-free manner. The method is geometry-inspired and outperforms a state-of-the-art LLM editing method on the task of generating Wikipedia-like biography entries. The paper uses Larimar, a class of LLMs augmented with an external episodic memory controller, and compares its performance with Grace, a method for LLM editing without altering its weights. The experiments show that both methods improve hallucination metrics, with Larimar achieving a Rouge-L score of 0.39 and Jacquard similarity score of 0.33, while Grace scores 0.49 for Rouge-L and 0.44 for Jacquard. The ideal case, where the latent vector representations for readout and write coincide, is also discussed, highlighting the potential for the decoder to attend to a compressed representation of what was originally written in memory. Larimar, a novel model, is introduced to mitigate hallucination in generated text by leveraging its memory to align input and output vectors. The paper demonstrates that Larimar's memory-computed readout vectors provide an opportunity for minimizing hallucination in generated output, simply by geometrically aligning them to right encodings. This is not available to SOTA methods for the same task like Grace, which encapsulates standard, non-memory augmented models by design. The paper presents observations on geometric properties of latent vector representations for pairs of texts in various stages of the Larimar pipeline. It shows that Larimar decoder arbitrarily distorts both the direction and the magnitude of incoming readout vectors, making it hard to connect the two vector types. However, when standard constrained generation is in effect in Larimar, there is a clear alignment between readout and write vectors. The paper proposes scaling up the length of readout vector by a factor of 3 to 4 for all samples to keep its distance to write vector approximately to a minimum and subsequently expect to get hallucination-optimized generations. This results in a maximum Rouge-L score of 0.72, significantly better than Grace's 0.49, and analogous benefits reflected in Jacquard scores. Furthermore, the paper discusses complexity considerations, comparing Grace and Larimar. Grace learns codebooks via minimization of a loss function during edits, which is an expensive iterative operation requiring backpropagation steps. In contrast, Larimar uses memory writes and reads, implemented as pairs of matrix multiplications, making it a lightweight operation. The research discusses the mitigation of hallucination in language models by leveraging generation constraint scaling. This approach is demonstrated through various experiments and comparisons with existing methods. The study focuses on the Larimar model, which incorporates lightweight memory primitives, and its ability to constrain generation effectively without requiring training. The use of scaling factors on readout vectors is shown to improve Rouge-L scores and Jacquard similarity, indicating better performance in generating coherent text. Additionally, the geometric alignment between input and output latent space representations is analyzed, highlighting the effectiveness of vector scaling operations. The research emphasizes the benefits of this training-free approach over traditional training-based methods in mitigating hallucination. It also references several related studies and models, such as Grace, BERT, and Optimus, for further context and comparison. Title: Mitigating Hallucination in Wiki Bio Generation through Generation Constraint Scaling. In this study, the authors explore the issue of hallucination in Wiki Bio generation, where the generated text deviates significantly from the actual information available. They propose a method called generation constraint scaling to mitigate this problem. This method involves scaling the generation constraints to ensure that the generated text adheres more closely to the actual data. The authors demonstrate their approach by comparing actual Wiki Bio entries with those generated using their proposed method. For instance, they present an actual Wiki Bio entry for Sir John Russell Reynolds, a British neurologist and physician, and contrast it with a GPT-3 generated Wiki Bio entry that contains significant inaccuracies. They then show how applying their generation constraint scaling method can improve the accuracy of the generated text. The authors also discuss the importance of understanding the underlying mechanisms that cause hallucination in Wiki Bio generation. They argue that addressing these issues is crucial for improving the reliability and trustworthiness of generated content. Furthermore, the authors highlight the potential applications of their proposed method in various domains, such as information retrieval, question answering, and content creation. They emphasize the need for further research to fully understand the benefits and limitations of generation constraint scaling and to develop more effective techniques for mitigating hallucination in wiki bio generation. Overall, this study contributes to the ongoing efforts to improve the accuracy and reliability of generated content, particularly in the context of wiki bio entries. The proposed generation constraint scaling method offers a promising approach for mitigating hallucination and enhancing the trustworthiness of generated information.